Hello, and welcome to Stratco's Pilot Plant Laboratory Operational Training video series, where we're going to be covering everything from pre-operational checks to the actual grease manufacturing process on a pilot plant scale level in our reactor and finishing kettle. One of the first things that we need to do before starting the system is to ensure that all the valves have been either open or closed or set to the right configuration per the operational procedure for the pilot plant contactor. Also, we want to ensure that the reactor internals have been inspected prior to starting any batch for quality concerns. And before we start the batch, we'll start the initial oil charge inside of the circulation tube in the reactor. The base oil addition and the quantity is especially important to ensure that the initial circulation is over the circulation tube. This is nominally somewhere around 3.2 to 3.5 gallons of material. Also, before starting the initial charge, you're going to want to ensure that you have enough gear oil in the lubricator system so that before you initiate the VFD, which you see here, that you're starting the lubricator pump and then you're initiating the VFD at a nominal half to quarter speed so that you can actually visually confirm that the initial oil charge is coming over the circulation tube. This is to ensure that you have proper circulation over the circulation tube for the base oil or other fluid materials as part of your formulation. Now once you have that circulation flowing, you can now see that base oil coming over the circulation tube and you get a nice good flow. You start seeing pulsing that could potentially mean that you have not quite enough material to get good adequate flow. Next step, we'll be starting up our MOCON thermal heating and cooling system to a nominal 250 degrees Fahrenheit to start the initial base oil heating process. Additionally, we'll be looking at a discharge pressure of our MOCON system to ensure that we're getting good flow through the piping circuit. This is to ensure that we get good heat transfer from the thermal oil to the actual process fluid from the contactor jacket. Note that the pilot contactor does not have a jacket on the circulation tube as the commercial system. Next up, we have the addition of our 12 HSA, which is in a flaked form through the top hatch. The next shot here just shows all of that additional 12 HSA slightly circulating through the process as it's continuing to melt. That 12 HSA can be added in slower so that it gives it enough time to melt and so that there's not as much of a lag between getting more fluidity throughout the circulation tube. In this next video and sequence some of the videos that you'll see here for educational purposes, you'll see that those flakes continuing to start melting until we get full flow at the optimal temperature that we're targeting. Please note that for very viscous materials, pressure may need to be added to the contactor to ensure fluidity across the circulation tube. In this next step, we'll be adding some calcium hydroxide through the top hatch through a powdered form. Some of the powder for the operator technician can be mitigated with an additional ventilation system that could be mounted right above the contactor. Next up, we'll be adding a little bit additional water as part of this particular procedural formulation. This will initiate steam and pressure buildup in the reactor as it's continuing to heat above the boiling point of water. you may notice a little bit of residual 12 HSA needing to be melted in that annulus before we start the ramp up of temperature. In this last video, you can see all of that material slowly starting to congeal and mix really well, and churning over the circulation tube multiple times. And after we've heated to our target temperature here, all of the water has presented itself into steam, and we can see that in our pressure gauge here. And now we'll be demonstrating the ventilation process as part of the contactor procedural steps. One of the main things you need to consider is just to ensure that when you're opening up the vent line, to open it up very slowly, to crack it up just enough to where you're slowly starting to get venting in the reactor. If you open it up too fast or too much, this could potentially cause some of the ingredients or materials to come out of the vent line, in which additional cleaning steps may need to be done after the batch has been made. Also, you want to ensure that wherever you're venting into is to a safe location and not potentially in a hazardous position to where someone can potentially get burned. Now for this particular procedural steps and training video exercise, we're doing a very slow controlled vent. This can be done probably a little bit faster if need be, if you're trying to ensure that all potential vapors are potentially getting out of the actual material. For this particular grease manufacturing process, we're just doing a slow controlled vent. But for other particular formulations, you could potentially vent multiple times, or for the pilot plant system, have to manually vent multiple times. But in a commercial scale system, this would be handled through automatic control valve that would be controlled to a set point. And once we've actually vented, we're going to ensure that all pressure has actually been mitigated prior to opening up the hatch, as you can see. The picture here shows that material flowing at a very hot temperature of a nominal 300 degrees Fahrenheit, at which we're actually demonstrating a quench addition step through the top hatch. Prior to starting the quench, we reduced the speed of the VFD to about 30 Hertz. This is to ensure that we don't get splash up on the technician, but the technician, as you can see, is wearing the proper PPE to avoid burn or the potential for a burn during this process. Also, manufacturers can configure a quench addition directly through any of the ports that are currently at the top of the reactor, where the hatch would not necessarily have to be opened in order to add that additional base oil. Now once the quench has been added and we've gotten to our correct temperature, we're going to be ready to start prepping for draining the actual reactor effluent material. So this will be done through the Strawman valve, which is a needle type valve at the bottom of the reactor. For this particular configuration of the pilot plant, we are going to be dumping this material into metal buckets and then transferring them into the kettle after they've been weighed before and after for material balance purposes. In other configurations, we may have a hard pipe directly from the reactor to the kettle, in which those particular configurations may be configured with weigh cells for material balance purposes. In this particular step, we're going to need 2 5-gallon buckets to drain all the material from the reactor. In this particular case, for this formulation for operational training purposes, this material is very thin, therefore there was no additional flush needing to be done. However, the VFD was running during that flushing process. That just helps to ensure that any residual material was actually flushed through the bottom hydraulic head. Also, pressure can be added to the reactor in order to improve this. Now, prior to transferring to the finishing kettle, we're going to want to make sure that all of the circuits have been flushed and decontaminated from going from one grease formulation to the other. So one of the main things that we're going to want to ensure is that we've got a good fresh base oil charge to the kettle, nominal 3 gallons or so, and then we'll get that all through the piping circuits, through the circulation pump system, get that through the colloid mill system, and then bring it all through the filter, which is also used for catching samples for finished material. In this particular video, we're just showing that flush oil being captured as it's circulating through the system at elevated temperature. Now, once everything's been cleaned, we're going to unhook the hose from the sanitary connection at the top of the kettle. We're going to open up the kettle by hooking the air compressor system up at a nominal 70 psi, in which the hydraulic system will initiate the opening process. We'll get the kettle fully open, visually check for quality concerns or quality reasons prior to any transfer into the kettle from the reactor. Once the material has been added into the kettle with the bottom flush valve closed, we're going to initiate the VFD on the kettle and start circulating or agitating the material in the kettle. And at this point, we'll be monitoring the temperature of the kettle. We may be cooling it at this particular time as we're trying to get the system primed and ready for initial circulation. This can be done either by normal flow with the grease from the kettle down through the flush valve and into the circulation pump, or the kettle system can be slightly pressurized to a nominal 20 to 30 psi. Once everything is starting to circulate and we've dropped our temperature to our correct target temperature, we can start the colloid milling process. Each setting on the colloid mill is 1/1000th of an inch. Once everything is milled, you can now see us taking the sample through the filter, and then we're ready for sample collection. I hope you found this video very informative. If you have any additional questions, please give us a call at 1-480-991-0450 or visit our website at www.stratcoinc.com.